Hi everybody, today I'm going to go over an introduction to solving exponential equations using the one-to-one property. If you know me, you know introduction means there's going to be more later, but what I want to do is kind of set the stage for what's going to come later. So we're going to do some kind of easy problems, set up what this means one-to-one property, and then we'll come back later and do things that are a little bit harder. So first let's start with one-to-one properties for exponential equations means b to the x equals b to the y, only if x equals y. So this says every input has a unique output for exponential functions. So let's start with a really easy example. Let's say I have 3 to the x equals 3 to the 5th. Hopefully you see that means that x would have to be equal to 5. So 3 to the 5th is equal to 3 to the 5th. Make it just a little bit bigger. Now I have 3 to the x plus 4 is 3 to the 10th. Again, once the bases are matching, I know the exponents have to match as well. So I'm going to say x plus 4 will be equal to 10, so x will have to be equal to 6. Let's change the base because there was nothing special about 3, and let's try 2 to the x plus 3 is equal to 64. Now the first thing we have to do is we have to make both sides have the same base. So 2 to the x plus 3 looks good. 64, you're going to have to go to your calculator and maybe try 2 to the 4th and 2 to the 5th. And then when you get to 2 to the 6th, you'll see that that's equal to 64. The bases are the same now. They're both 2's. I can set x plus 3 equal to 6, which says x is equal to 3. If you want to check it, you could just go back over and go 2 to the 3 plus 3, which is equal to 2 to the 6. Put 2 to the 6 in your calculator and you will get 64. So let's change it. I'm changing it to this number e, and we'll talk about e. E is a really special number. It's kind of close to 2.71828. It's exponential in nature. It is what happens kind of if you let compounding happen on its own, but again, that's for another video, but I want to mess with you when we're in this one. So it says e to the 2x plus 3 is e to the 15. The base matches. They're both e, so I have 2x plus 3 equals 15. We're just going to solve this linear part now. 2x will be equal to 12, and then x will be equal to 6. You could plug the 6 in. You know, 2 times 6 is 12, 12 and 3 is 15, 15 is 15. So the e is just kind of setting the stage. It is the base of our equation, but that e could have been a pi or the square root of 2. It doesn't matter. We're just making sure the left and the right are the same. So let's try a little bit bigger with e. I have e to the x squared plus 9 is equal to e to the 10x. The first thing I do is drop the e. I have x squared plus 9 is 10x. I'm going to bring the 10x over. So I have x squared minus 10x plus 9 equals 0. And then we're going to factor. So this started as an exponential. It has turned into a quadratic. We're going to factor. Factors of 9 that give me 10 are 9 and 1. I have x minus 1, x minus 9. So x will be positive 1 and x will be positive 9. So let's change it a little. Let's try a fraction. I have 1/6 to the power x is 2/16. First thought should be I need them to both have the same base. So think back to 1 over 6. I could write as 6 to the negative 1. Remember that fractions are negative exponents. Still have the exponent x. And then again, you go back to your calculator and you go, okay, 6 squared is 36, and then 6 cubed is 216. So on the right, I have 6 cubed. Remember when you have a power to a power, you multiply. So I have 6 to the negative x is equal to 6 cubed. That means negative x is 3, so x is negative 3. Let's try that again. This time I have 1/2 to the 4x plus 3 is 32. So hopefully it pops at you. Hopefully you see the base that we should be using. The 1/2 becomes 2 to the negative 1. That's to the 4x plus 3. And then 32, mess with your calculator, you'll get that it's 2 to the 5th. So I have 2. I do negative 1 times 4x plus 3. That's negative 4x minus 3. There's 2 to the 5th. So I kind of drop the 2's. Negative 4x minus 3 is 5. I push the 3 over. Negative 4x is positive 8. So my answer is x is negative 2. So just take your time, do each little step, but really what you're concentrating on is how do I make the bases the same? So we're going to stop with this one, which is a little trickier, but this is kind of where we come back in the future. I have 4 to the power x plus 1 is 8. So you can try this in your calculator if you want. You could do powers of 4. 4 goes 4, 16, 64. I skipped right over 8. 8 goes 8, 64. I skipped right over 4. So what you kind of want to do here is think, well, is there something smaller I could use? Which I can use 2. So let's start there. 4 is 2 squared to the x plus 1. 8 is 2 cubed. So you want to think about how can I make the bases the same? And sometimes it's not going to be obvious. Sometimes you have to think smaller for us to be able to do this. I'm going to multiply this 2 by the x plus 1. So I have 2 to the 2x plus 2 is 2 cubed. So 2x plus 2 is equal to 3. 2x will be 1, and that leaves me with x is 1/2. So again, just a quick introduction to think, what are we talking about when we say one-to-one property for exponential equations? We'll make this even bigger a little bit later, and yes, there will be times when you can't make the bases the same, so we'll have to do something completely different to solve there, but before we do that, we need to talk about logarithms, so I'll see you back later. Bye-bye.